Hi, we are going to discuss about analysis of algorithm in this video. First, I want to tell you what is algorithm. For that, we are going to take example of the preparation of it. The steps required for to make an omelette is we should have egg, we should have a frying pan, we should have an oil. After that, we would break the egg into the ball and then add some salt and spices, add it to frying pan, wait for some minute, and yes, we are ready to eat. So these are all the steps required to make an omelette. Accordingly, there is some steps required to make a program run, and that is called algorithm. The basic structure of program, the steps, the procedure, that is algorithm. Now, why we analyze algorithm? For that, I want to take example of traveling from city A to city B. I have four mode of traveling, that is by flight, by bus, by train, by bicycle. So if I take flight, the ticket cost would be too much high, but the time would be too much low. So yes, it's efficient in time. If I take bicycle, the cost would be too much low, but the time would be too much high. So yes, it's also efficient, but in cost, in money. So it whole depends upon the situation that we have and the convenience that we want to choose. Similarly, in programming, it all depends upon the time and space that our computer have. So if I take example of computer, I would take example of Windows. For example, if I on my computer I have SSD, then it would require 5 to 10 seconds to open my Windows. But if I have HDD, then it would most probably take 30 seconds to 1 minute depending upon the configuration of my computer to open my Windows. So it whole depends upon the configuration of computer. Likewise, same for algorithm. We use optimization of algorithm according to our need and according to the situation that we have and configuration. Now you could see analysis of algorithm page. There is three symbols O, theta and omega. These three symbols are also known as asymptotic notations of algorithm. We will discuss about later, but I want to tell you now that this is called big O, this is called theta and omega. Now, what is order of growth? So simply I would say function f is said to be greater than gn. That is the rate of function fn is always greater than gn if the limit of n is tends to infinity and the value of this expression is infinity, because the fn is too much high and gn is too much low. That's why if we divide a too much low value, too much high value with too much low value, then the answer would be infinity. Likewise, if gn is too much small and fn is too much huge, for example, if gn is 1, fn is like tends to infinity, like we would say like infinity, then yes, 1 divided by infinity would be 0, but infinity divided by 1 would be infinity, because gn is less. It's mentioned in the order of growth definition. After that, we are going to discuss about some logic that we are going to use in analysis of algorithm. This is C, that is called constant. It's the lowest order and the best case, and this is highest, that is n to the power n. You should learn this and keep this in your mind, but it doesn't require, but it would help you. But I would suggest that as you practice more and more, you would learn these, that which is best. So if I say to solve any problem, there is two ways. First is ignore the lower order terms, and second is ignore the leading constant. Remember these two lines. We will use these in the upcoming questions. Now let's take a first look on the first question that we have here. There are two functions in this question. First is fn, second is gn, representing their own expression. So what we have to do, we have to drop the lower order term, that is C2, as it is written here. Ignore lower order term. So we will ignore the lower order term. We'll drop this. After dropping this, we have C1 log n for fn. For this, we would ignore the leading constant. The constant is C1 here. Hence, the only remaining part is log n. So for log n, that's only term that is present in for function fn. Similarly, for function gn, there is a constant cf, that is lower order term. We would drop it. The another lower order term is log of log n. As you could see, the log of log n is lesser as compared to n, hence is lower order term. We will drop this. We have c3n. For c3n, we would drop the leading constant, that is c3. We have only n. Hence for gn, we only have n. So the time complexity of both the function would be f of n, because n has more priority as compared to log n, but the log n has much lesser time complexity. Hence, the best time complexity is of fn, because log n takes less time as compared to n. You could see. So here it is written, what is time complexity? What is the definition of time complexity? Amount of time taken by an algorithm to run. That is called time complexity. Coming to our next question. Same question is there, which is the best algorithm? We are dealing this in time complexity. There are two functions, fn and gn. Now try to pause this video and try to give the solution on your own. For function fn, you would drop c4, you would drop c3n, you would only have cn square. After dropping c1 from this n square, because it's leading constant term from this, hence for n square it would only be n. For gn, you would drop c7, you would drop n. Here why would we would drop n? Because there is also n, and that also has log n, so it is greater than n, so that's why we would drop n instead of n log n. Hence we would drop c5n, c7n, and we only have c6n log n. From this part, we would drop c6 because it's said ignore leading constant. We would ignore the leading constant, then we would have n log n, and the time complexity of this would be log n, because after multiplying, we we make it to the lowest term. So for this, gn has only lesser time complexity as compared to fn. Now coming to our next part, that is asymptotic notation. As I told you earlier, this is called big O, this is called theta, and this is called omega this time. So now let's discuss about all these three. So big O, it represents exact bound or upper bound. Theta, it represents exact bound, and omega, it represents exact or lower bound. We mostly prefer to use big O because it represents exact bound and upper bound. That is called upper limit. So that's why we use. Now let's comes to big O notation. That is big O. So you could see the definition that fn sat to be big O of gn if there exists constant c, and this is the expression. This is not for the use, but it's only if you want go deep dive into this case, then yes, it's for you. You could write this and try to solve this question on your own. You would came to know that why we use big O notation more as compared to theta and omega. Now, if we say that Fn is equals to Gn, there is constant C and numbers such that Fn should be less than Cgn. Here C is constant. So this is all definition. Now we have to find the big O. Big O is also a type of time complexity. As I told you earlier, there are three types of time complexity. That is big O, theta and omega. Here we are dealing with big O. Now the expression is Fn equals to 4n plus log n and 30. What is the time complexity? Here you could see the time complexity. There is n, there is log n. We will drop the constant that is 30. We will drop also the lower order term that is log n. We would have 4n. From 4n we would drop 4 as its leading constant. We only have n and n for that it's the time complexity, that is big O of n, that is written in this way. And as I told you, it is most useful case. And there is some note, the most useful case is worst case. And as I told you, why big O of n is useful, because it tells you about worst case. Now there is some examples of big O. For example, if you are dealing with big O of n, then these are all part of big O of n. Like n plus 1000, it belongs to big O of n. N by 4, it belongs to big O of n. 2n plus 3, it belongs to O n. So it's all belongs from big O of n. Now if I talk about O n square, then n square plus n square is belongs to big O n square, because if we drop lower constant, there would be n square. It belongs to n square. 2n square, we would drop 2, we would left with n square. It belongs to n square. N square plus log n, is lesser as compared to n square in terms of time complexity. For this part, n square by 1000, it belongs to O, big O of n square. There it's all constant, like 1000 is constant, 1, 2, 1000, 10,000, 10 to 10, 1 lakh, 1 million, all. So it belongs to constant, and constant is a big O of n. Now let's look into next part, that is big omega notation preferably. So it represent lower bound. So talking about the definition, this is the definition. If you want to go deep dive into this situation, you could note down and do some numericals, but it does not required for learning data structure and programming. Talking about the examples of of omega notation, these are all the examples of omega notation. That is, you could see that n by 4 belongs to on, no problem. N by 2 belongs to on, no problem. 3n belongs to n, no problem. But the problem comes here, n square belongs to O, omega of n. How is it possible? Because as I said, it represent lower bound, because all the all the time complexity should be greater than n, not lesser than n. So as I told you, in big O, the time complexity should be lesser than, but in this it should be greater than n, and all should be belonging to this. Likewise, if I say what are the examples of omega n square, then the example of omega n square would be from this part to this part. From n square to n square, n to the power n. This all belongs to n square. But 3n, it doesn't belong to n square. I guess that you would understand. So here it is written, if Fn is equals to omega Gn, then Gn is also equals to omega Fn. We are trying to say, if a function is equals to time complexity of a function Gn and it is represented in omega notation, then the vice versa is also possible for big O. Omega notation is useful when we have lower bound on time complexity. It is written because sometimes we don't have upper bound. We would came to know after practicing some question. Let us look into next part, that is theta notation. It represents exact bound from lower and upper side. Exact. It is useful if we know exactly what is gonna happening, but as it's a computer, so it's very difficult to decide what's going to happen, what's going to predict. So this is the definition of theta notation. Let's talk about theta notation. So if Fn is equals to theta of Gn, then Fn is equals to O, big O of Gn. And for omega, it's also the same. So in this part, all the three, theta, big O and omega, all three functions are equal. And yes, it's possible because if a function has exact time complexity, like we have made up an algorithm and we came to know that its time complexity would be n, then the big O would also be n and the big omega would also be, because we know exactly that the theta is n. That's why theta is useful to represent time complexity when we know exact amount, but it is really difficult to find exact, but yes, it's useful. Here you could see only terms which have n square in it as the time complexity that is related to n square, but here you would see this is 2 log n, 2n log n, and but there is a plus sign, that is 4n square, that's why it belongs to theta n square. Now coming to our next question, analysis of common loop. Here we would analyze some common loops depending upon the time complexity. First part is like we have a simple loop for int I is equals to 0, it runs less than n, and it is increasing it by a constancy, and there is some work theta 1 going on. So the time complexity would be theta n by c, and after ignoring c, time complexity would be theta n. Try to pause this video and guess the output of this loop. For this loop, it is increasing it by multiplication of c. So here you would see the first term would be n, 1, the second term would be c, third term would be c square, and so on. It's running for n times, so let's take for k to c to the power k minus 1. If we take, so it is running less than n. If we take log both sides, you would see k minus 1 came to this side and log n this side. After solving this expression, you would see that k is less than log of n plus 1. After dropping this side, you would see that yes, theta is log n. Coming to our next question, we could see the loop is running from I, that is equals to n, and from n to 1, and the expression that is going on here is it is dividing itself with a constant c. So there is some theta work going on. It is similar and opposite from previous one. So here you could see as it is running from 1 to n, and it is multiplying itself with a constant, that is it is 1, then c, then hence it's a log n. Similar this is for this. Coming to our fourth question, for int I is equals to 2, from 2 to n, it is increasing the value of I, of power, that is for I, and there is a constant c, and there is some theta. For solving this question, we are going to work in detail. So the value of 2 of I is 2, and the value of I is 2 to the power c, then the value of I is 2 to the power c, and it's going on. For example, like assume k times, so it is, if it's k times, so 2 to the power c and k minus 1. We have mentioned k minus 1 because we have extra 2 here, so to not include 2 here, because it is here, we are subtracting 1 from k. Similarly, so it should be always lesser than, so I, that is 2 to the power c to the power k minus 1, that is less than n, and we write that we take log as we done in the previous example. Here taking log both sides, so taking log both sides. Solving this question, we would came to this part, from this to this. So here you could see the k is less than log of log n, and hence constant is here. That's why this is the time complexity. Coming to our next part, that is a function. Here you could see there is function and there is 3 loops going on. First loop is from 0 to n. It is initializing itself for always 1. Then it is running from 0 to n. It is increasing itself by the multiplication of 2. It is now the third part. It is going from 1 to 100, and it is increasing by 100. For first part, the time velocity would be theta n because it is running from 0 to n. Second part would be log n because it is running from 0 to n, but it increasing itself by 2. That means that is the work done by the first part is half as compared to second. Second is doing half the work, and for third it is running for a constant period of time. There is no n, there is a constant number, that is 100. That's why it's running for a constant time. So after ignoring lower values, we have theta n. After ignoring lower value, we would remove theta 1, we would remove theta log n, we have theta n. Coming to our sixth question, I would suggest you to pause this video and do this on your own. For that question, you could see there is a nested loop. This loop, I guess, run for theta n. For this, it would run for theta log. We multiplied this and n into log n, that is n log. That is the thing. After that, we are going to analyze a recursion. Analysis of a recursion. There is an example of recursion, void function, and the return value is int n. So if n is less than equals to 1, it would return, else it would print abc. So for example, if we make the value 1, then yes, it would return. But if we make the value 10, then it would print abc 1 time, then 2 times, then 3 times, then 9 times. then for the 10th time it will return. So what's the time velocity? The time velocity would be n minus 1, and there is a theta 1 that is running for a constant time, and this is running for because as I told you, if I run it for 10, like int n is equals to 10, then this will print for 9 times, and this will run for 1 time, that is 9 9 n minus 1 10 minus 1 9 and 1 time. So here, after ignoring this constant value that is not initialized here, the time velocity would be this, but for the constant time the time velocity would be theta 1. So coming to our second example, we have void function. The returning value here is n, it is less than or equals to 0. For example, if I am running here like n int n is equals to 10, it will print abc for 5 times, because 10 divided by 2 5. Then it will also run abc for the 5 times, so it is running for 2 times but dividing by 2. So time velocity of n would be n by 2, but it is as it is running for 2 times, hence we are multiplying it with 2. And for the last case, it is running for 1 time, that is theta, and that is constant. If it is 0, then it would run for theta 1, that is constant. I guess that you learned something from video, so we will meet into the next video talking about space complexity and further some details in time complexity of some trees.